All right, let's jump into 240408 from Too Tall Toby. And this level 5 tube breaker is really interesting. We got some pretty complicated drawings. We got 2 ribs, a lot of diameters, some things that maybe aren't quite obvious. I definitely would have included a section view in this drawing, but we can make it work. You'll kind of see in this preview here that there's kind of 2 cylindrical shapes, and as happens a lot in these Too Tall Toby exercises, one of the shapes would kind of slice through the other shape. So frequently we might want to extrude this as a tube, but if we do, then we have to go back in and kind of clean out the inside. So if we start solid and then empty out both of the shapes, we don't have that issue. All right, so we are in grams, we're in steel, and it is time to get started. So even though this is super complicated looking drawing, lots of information all over the place, I am going to just start this with an extrude on the top plane. I'm not going to use sketch regions. All of the dimensions are based off of this main cylindrical shape. So we're just going to add a circle, and right now I'm just making this bottom plate. So I want the smallest diameter. It's on the right side view here. Didn't mean to do it like that. Middle click, and we'll set our smallest diameter 25. And then I'm going to add the shape around the outside. I could do a rectangle with some fillets added to it, but let's use the palette tool and find a rounded rectangle. Double click, place it, and we don't want it centered. We don't want it really on any of these we don't want it to click to anything. We need it to like dimension on its own. Yeah, something like that. We'll have to place the dimension when we've got it placed. Okay. So overall height is 80. Overall width is 120. The radius is 15. And the distance behind that central tube is 30. And we are placing it, we're not using this dimension, we're using the side dimension. A couple of ways to do it. One of my new favorite ways is to hold down Control and select multiple and drop the dimension on that way. 73. Okay, so there's all our starter geometry. I'm not going to add the holes, I'll add those a different way. And we'll hit check mark. So this goes up 12, as shown in the right side view. You always kind of look and see whether everything's based off the bottom or kind of the middle. So everything's based off the bottom, so I want to have that consistent top plane. Let's go ahead and start with the big tube. So, I just said that, and now I need to change it. I actually started to sketch on the top surface. I want to sketch on the top plane. Then when I extrude it, I can give it the full depth. I can project this inner circle. It just wants to grab the one edge. If you hold down Shift and grab the other end, it'll get the whole loop. Green check mark. And let's drop a circle that's concentric to that. And that's going to be our outer diameter, which is shown in the right side view, 55. I don't want to remove material. Let's add material. Overall height of that extrude is 80. Again, I'm not going to hollow that out yet. I'm going to leave that one in there, but that's it. We're going to go onto this plane and extrude this kind of side circle here. And we're going to make it solid. All right, so let's see here. The 40 for the outer diameter is shown in the top view. And that's going to be located 35 from that central axis and a height up of 50. Okay. And see how we've got this kind of shape in the middle here? So if we did hollow this out, let's say with, I'll just show you and we'll undo it, with a diameter of 25. See how you'd have that shape that would cut through on the inside. So we'll undo that. We don't need that shape. And we're going to extrude this. So how far do we extrude it? Well, in the top view, it shows that it goes 40 to the right and 50 to the left. So we'll leave this 40 in here going to the right. And in options, we'll add a second side that's also a variable. And we'll set that depth as 50. So you can have extrudes that go 2 different ways, or actually both the same way, give it different numbers. Okay. Before we hollow it out, let's add those ribs. We got 2 ribs. We got a rib supporting our side plate. So if it's showing trajectory rib, you want to drop down and grab a profile rib. Sketch that on this right plane. Okay. If you haven't used the clip model option, that's really helpful. Kind of lets us see what's happening inside at the sketch plane. We'll just drop a horizontal line. Well, that's interesting. I thought I clicked on that surface. That's all right. I'll grab the coincident constraint and make those stick to each other. And we'll dimension that line to the left edge of the base. And that has a distance of 8. Okay. With the profile rib tool, what's happening is you're identifying kind of where the geometry comes out to. Now this gave me the right direction. A lot of mine go the wrong direction the first time. Okay, so flip the arrow if you have to. And this has an overall width of 8, and it is centered. There are options, so you can make it go one way, the other way, or centered. We're going to add another profile rib onto the front plane. And this one is just going to be a line that is adjacent over here to the edge of the bottom of the part, sticks to the edge of the main cylinder, and that gets dimensioned with this angle of 56. It looks like it comes right up here to the edge. It's really close, but not quite. Again, you don't have to draw the entire closed shape. You just draw the line. And that also has a width of 8. So profile tool, I talked about in my last video. You can go back to that one. But really powerful tool, really helpful. All right. So we need to hollow out these tubes now. I'm going to do those with revolves. Let's start with the main tube. So we'll do a revolve on the front plane. Make sure you have your geometry center line, which is going to be your axis of revolution. I definitely want to clip the model here. That's going to help. So the material I'm going to remove will go up like this, and then down and in and down and over. So that's going to be the cut that I'm going to remove. When you do your sketch inside the revolve, you get the full diameter gets added for you. If you're just doing a sketch and it's agnostic of whatever the feature is, it won't automatically give you this these revolve diameters, which are really nice. And then this dimension is 20. Okay, so that is our axis of revolution, our geometry. We're going to spin that 360 degrees. It's automatically removing material because it's fully contained. Okay. And then we want to do the same thing over on this piece, but we don't have a datum plane there yet. So we'll make a plane. It's going to be parallel to the front and going through that surface. If we can set that to parallel and through, that works. One of the things I love in Creo is when you're creating datum planes, you select 2 options. It kind of gives you what works. You don't have to tell it, I'm going to make a parallel plane through an axis. It kind of gives you the options based on what your references are. Okay. All right, on that datum plane, we are going to revolve. Again, I definitely want to use that clip model. It's going to just kind of help make things a little clearer. Add that datum center line. I don't have an axis showing up. Let's get that axis showing up. There we go. All right, and we are going to come in at an angle, and the dimensions on this cut are interesting. it's pretty obvious I have this diameter on the left side of 33, and I have a diameter on the right side. Oop, something got a little weird there. What happens if I make this one 25? There we go. And maybe that actually wasn't that obvious when you first started. The hole going through this tube is narrower on the right side than it is on the left side. So in this front view, you can kind of see that taper and that 8°. Let's get that 8° in there. Right, so we've got 25 on the right side, we've got 33 on the left, we got 8° angle taper in there. When you are revolving, make sure that the line that's on the center line is continuous. So we do run into issues when we're revolving if I were to break this into two separate lines. Okay. So again, we are removing the material inside there, and notice how it's cutting out that main tube. All right, we are so close. So the last thing we want to do is add these counterbore holes. There are 3 of them, not 4. Start by creating a sketch. And we're just going to locate where those holes are going to be located by using datum points. So I'm going to select the arc, wait till it highlights the points, and then put a datum point on the center. And use those holes to place, use those points to place our holes. We're going to use simple drilled holes with a counterbore. We want to make sure the sketch or shape tab is open. The hole diameter going all the way through is 6, and that is a through hole. The depth of the counterbore is 4, and the diameter of the counterbore is 12. Okay. All right, so kind of challenging to read through there. Maybe I made it seem easier than it was. That was the second time I've done this part. So it always gets easier the second time. We're looking pretty good. We're gonna try our value. And fantastic. All right, so you'll see that I previously did this in just about 20 minutes, cut the time down significantly the second time through. The second time through something is always easier. Really interesting part, so much. It really feels like you want to start by making these tubes, maybe one or the other, but a lot of times when you have any of these geometries that's intersecting each other, start with the big outer shapes and then remove the inner shapes as a separate feature. Otherwise, you're going to have to come back and do them again anyways. Don't forget the power of the rib tool. Don't forget that clip model option. Okay. So a lot of fun things in this level 5 Too Tall Toby challenge. Take care.